I will soon embark on a trip to Mars, an analog mission, a simulated environment in the Utah desert. Although much warmer than Mars, the desert's location, terrain, and appearance are similar to the conditions on the Red Planet. And as soon as we arrive at the Mars Analog Research Station, we will be literally living on Mars. I will embark on this mission together with medics, engineers, psychotherapists, academics, and a colony of cyanobacteria, a group of multifaceted, hyper-old microorganisms.
What is it?
It's a cyanobacteria. They are very, very tiny. You cannot see it with your eyes. You need to use a microscope in order to see them. They are very tiny, 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 and very, very, very old. They change the world. They manage to turn sunlight into their food in order to produce oxygen. So all other animals could live happily on Earth, including humans.
Where can I find them?
Well, you can find them in the ponds, in the sea, in the lakes, wherever.
Can I eat them too?
Well, it depends. Because if that lake is polluted, then they will be very unhealthy for you.
Where can I find healthy ones?
In some parts of the world where water is clean, people are growing those bacteria for food. Actually, when they are grown in a clean water, this green bacteria is very, very healthy.
Where can I find them? Are there any nearby?
Well, you can find it in a shop. However, people wanted to earn money on this bacteria. That's why they build big factories to produce the bacteria. They were producing more and more and more to earn more and more money.
Money? What do people need money for?
To have power, to go far, to grow bigger, to be stronger, to dominate others.
Can you find these bacteria on other planets too?
Since this bacteria is so healthy and so easy to grow, there is an idea to bring it to Mars. So the first people on Mars can eat healthy food, healthy green food, as cyanobacteria can produce.
Why do people want to go to Mars?
Well, because people build factories, people take things from ground, and when you build factories, you also destroy Earth. You pollute it, you use all the resources which are there. Maybe people are looking for another places to do the same, because Earth cannot serve this purpose anymore.
What do they do on Mars?
Well, probably the same as on Earth. And when they will exploit it, when they will use what they wanted from it, they will probably look for another planet to be on. Another planet to be.
From a Martian perspective, I will meet a transmedia narrative about humans' urge to conquer and the impossibility of owning what can be seen with the naked eye. Bacterial, terrestrial, and interplanetary colonization will be analyzed through an artistic and scientific narrative, which will include an interactive bioreactor. So we've got here 1 liter 250 milliliters of water. I left it overnight so the chlorine can evaporate. It's exactly 5 times more of water than I will be planting of Spirulina plantensis to it, which will be 250 milliliters. But first we need to prepare medium in which the spirulina will live. For this amount of water, 1 liter 250 milliliters, we need, I calculated it earlier, 26.4 grams of dry nutrition media spirulina. It's a mix of various microelements. Spirulina, I mean, this kind of cyanobacteria likes to eat. We can measure it now. So I said 26.4. Let's see how much is it. But what we want to do is to put it in this water. Spirulina. And stir it for around 10 minutes. So it's really diluted and it's not so easy to dilute. A bioreactor is the container where the bacterial culture grows. I am currently developing a bioreactor that can provide spirulina with an optimal environment that also mimics the day-night cycle on Mars. In this case, optimum level means the right temperature, pH, mixing, light, gas transfer, feeding and harvesting. We are doing it almost for 10 minutes and it's not perfect. There are still some little pieces of that powder, but I think we and spirulina can live with it. Yeah, so now it's the time for spirulina to have its new home. So I was storing it for the night. I mean, it arrived yesterday, but I was storing it for the night in the fridge. So the degeneration is slowed down. This morning, now we have afternoon here, I took it out from the fridge because it's better to keep similar temperature of the culture and the medium. So I hope they are quite the same. And yeah, here we have 1 liter 250 milliliters, and then 5 times lesser of the culture is 250 milliliters. Wow, it has quite a smell. It's around that. I will leave another half in case this experiment won't work. And now we gently add this culture on top of the water without stirring. That's it. Now we need to keep this in a sunny place, not too sunny, or under the lamp. For 2 weeks it will be quite crucial time for the spirulina because it needs to get to the new environment, get used to. So I will not be stirring it, I will not be adding artificial temperature. I will not be doing anything to it. Now we just need to place it with the source of light so it can do its job, photosynthesis. In this setup environment, I will plug a pH sensor that will not only indicate the growing culture's condition, but will also give impulses to a bot to post on social media. Through algorithm, the growing spirulina will post thoughts and links collected during my research on cyanobacteria. They will be selected in various times, frequencies, and contexts, depending on spirulina's pH. This will incite an interspecies communication and critical stand on issues with hate speech bots. The research on this part of the project was conducted during a 2-month online residency program in collaboration with Janina Prudenko and with the support of Adam Mickiewicz Institute in Warsaw. Through the discussions with Janina, I was introduced to a pioneering form of DJing known as Ukrainian light music, as well as the Soviet space program, which have influenced my work on the bioreactor. This project represents years of passionate work with bacterial fermentation, and it brings forth my two main backgrounds, art and science, in order to seek an answer to the following questions. Could bacteria serve as a metaphor for space colonization? What lessons from Earth's colonialism can we apply to our interplanetary future? What can we learn from non-human organisms and colonial wrongdoings to avoid the crave for power and domination in space? Can microorganisms and the universe give us the knowledge we need to live on Earth?